Hello everyone. Once again, this is yours only, JTK, giving you an overview about plastics. This time, it's with a presentation and not my face. Okay, let us see the plastic for beginners. The word plastic is derived out of a Greek word called plastikos, and basically what it means is capable of being shaped or molded. That is what the meaning of plastic in Greek. Plastic in today's world mainly classified into three categories majorly. Of course, when we get into the deep and deeper view of plastic, there are many more classification. At a basic level, these are all the three major classifications. One is called thermoplastic, and another one is called elastomers, and one more is called thermoset plastic. A dotted view, you see three small pictures there, which gives you an overview about how each of these plastic, the molecular structure they are. So you can easily make out that elastomers in the center is more distanced linking, and the one in this front, that is thermoplastic, is a bit more concentrated close linking compared to elastomer, and when you look at thermoset is more highly concentrated the cross linking. So this is what this picture shows. So I will get you an overview about all these three plastic bit in more detail, giving you a basic update about the plastics. So based on these three classifications, let us see what does each of these means. So elastomers are characterized by wide mesh cross-linking of knotted molecular chains. These type of cross-linking means that materials have a high level of dimensional stability but are still elastically malleable. By applying a load, these chains become disoriented, but when you remove the load and relax them, they come back again to the original stage. So we all know them. Elastomer has mostly rubber and rubber parts. So the second one is thermoset plastic. In an individual molecular chain, the thermoset polymers are characterized by three-dimensional closely meshed cross-linking. This property means that they can no longer be shaped after hardening. They also cannot be melted. However, because of their strong cross-linking, thermoset polymer do offer a good chemical resistance and high level of thermal stability. Has begun hard and brittle. We all know them mostly as GRP, FRP, SMC, DCPD parts. So one more is thermoplastic. Thermoplastic polymers are plastic in which, unlike elastomer and thermoset plastic, the molecular chains are not cross-linked. They consequently demonstrate a elastic behavior and are thermoformable. That means melt them, weld them. This formability is reversible. In other words, one can say it can be repeated as often as required, as long as the material is not thermally damaged by overheating. We all know mostly has injection molded parts And one more example could be blow molded parts, roto molded parts. These are all the certain examples to give thermoplastic. In these processes, mostly we use thermoplastic material. To give you a brief overview of more commonly known material to distinguish between thermoset plastic and thermoplastic. Both thermoset plastic and thermoplastics mainly sound similar, but they have a very different properties and application. Of course, some could be very common. The first physical difference is that thermoplastic can be remelted back into a liquid. Butter can explain more relevance in this case. For this, butter can be melted and cooled multiple times for various shapes. So, whereas thermoset can be compared with bread. So, thermoset is more similar to bread in that once it is attained the final shape or final position, it cannot be reversed or gone back to the original stage, and any additional heating could lead to burning and not going back, unlike in butter case. So it's a kind of reference from plastic to a day in day out material to give an overview what it means. Let us look further. Let us compare thermoset plastic with thermoplastic. So let us understand these two different plastics and where they behave at a process, where they are featured, and what are all the advantages and challenges each of them has. So thermoset plastic contains a polymer that cross-linking together during the curing process to form an irreversible chemical bond. The cross-linking process eliminates the risk of product remelting when heat is applied, making thermoset ideal for heat-related applications. Thermoset plastic significantly improves the material chemical properties, provides enhanced chemical resistance, heat resistance, structural integrity. Thermoset plastics are often used for a sealed product due to their resistance to deformation. What are all the advantages we have with the thermoset plastic? More resistance to high temperature than the thermoplastic, highly flexible in terms of design creativity, different possibilities of different thickness you can manufacture with these material. They provide excellent aesthetic appearance, high level of dimensional stability, cost effective for low to medium range of volumes, and specific application based on the nature of use. What are all the challenges in thermoset? They cannot be recycled, and once you attain the surface finish, there is more difficulty to attain a high level of surface finish, and you cannot remold them or reshape them once they attain to the final shape. Let us look thermoplastics. Thermoplastics softens when heated and become more fluid as additional heat is applied. The curing process is completely reversible, as no chemical bonding take place. This characteristic of thermoplastic allows to be remolded and recycled without negatively affecting the material physical properties much. So what are all the features of thermoplastic? These are multiple thermoplastic these days. There are multiple thermoplastic resins that offers various performances benefits. Most materials are commonly of high strength, shrink resistance, easy bondability. Depending on the resin, thermoplastic can serve a low stress application such as plastic bags. High stress application has mechanical part. So advantages with the thermoplastics are they are highly recyclable material. Aesthetically, they give a superior finish, high impact resistance, remolding and reshaping capabilities, chemical resistance, hard crystalline rubbery surface options, eco-friendly manufacturing environment. And challenges connected with thermoplastics are generally they are more expensive in comparison to thermoset material, and they can get melted if heat is applied. So now that we have understood these main categories of plastic, let us look thermoplastic more in detail. How are they classified? So here is a view which gives an overview of those classification of thermoset plastic based on where they are processed. So at the top level there are 2 or 3 classification and the major level based on the type of molds or the process they have been used. So one is open mold process, closed mold process, pultrusion. And within the open mold process, there are further bifurcated into hand layup, spray layup, and in closed mold process, they are further classified as resin transfer molding process, which is widely known as RTM process, light RTM process, which is basically infusion based, unlike in RTM, which is injection based. Vacuum infusion process, which is also known as VIP. Compression molding process and sheet molding component, SMC. Liquid composite molding. Direct long fiber thermoplastic molding. DCPD or reaction injection molding, which is also known as RIM. And in pultrusion, it is a continuous composite manufacturing. I have worked extensively with the ones you see in green letters. So let us give one more view about what is open molded process. Open mold method allows a rapid product development cycle because of the tooling fabrication process is simple and relatively low cost. So further, let us look at the hand layup process. Most simplest of all, the glass reinforced plastic or fiber reinforced plastic fabrication process is hand layup process. Hand layup process is used in a low volume production of a large product. Of course, the small product can also be manufactured. So we can have a part with a clear or pre-pigmented gel coat has a finish on the part, the surface we want to. So basically the gel coat is applied on a mold surface. So the picture below you see, the one highlighted here in the green is a mold, and one you see here, the line between the mold and the these two pictures, the line can be called as fiber, and what you see here getting poured is resin, and the hand with a roller, what you see is a kind of a process where the rolling take place to take out the entrapped air. So basically the pigment or a gel coat is applied on the mold surface to get a high quality surface. Once the gel coat is cured, the glass reinforced mat is placed on the mold and then catalyzed resin is poured, brushed or sprayed on. The manual rolling then removes the entrapped air, compacts the material or the composite, and thoroughly wets the reinforcement with the resin. The additional layers of fiberglass mat and the resin is added based on the thickness requirement. The catalyst or accelerator initiate the curing in the resin system, which hardens the composite without an external heat. And this process of converting liquid into a hard is called exothermic reaction. Let us look at spray layup. This is like a hand layup in a simple way. The spray layup offers a greater shape of complexity and faster production, and it also reduces the human efforts. Spray layup utilizes a low-cost open mold, room temperature curing resin, and this is ideal for producing large parts in a low volume moderate quantities. As you see in the picture, the chopped fiber reinforcement and catalyzed resins are deposited into the mold surface by a chopper or a spray gun. So basically in this process what we see here is this is where the fiber comes in, and there will be an mechanism which will chop the fiber, and here what you see, the two pipes will give resin into the mold and pressure, and the chopped fiber along with the resin is sprayed into the mold, and same like in open mold process or hand layer process, once again the roller is being applied on these sprayed area to remove the entrapped air. Let us now look at close molding process. Close molding process are ideally for efficient fabrication of consistent quality parts at medium to high volume requirements, with relatively little wastage and harmful emission in comparison to open mold process. There are many sub-processes within this family known by various names. I will come to them in a coming pages or coming now. Classification and cost factors. I will also show you a kind of a chart, which will give a kind of a thumb rule, in terms of volumes and cost factors. Each of these process can be looked at, and this is just a guideline and nothing hard and fast. So if we compare these different closed mold processes or these processes, how much the volumes each process is suitable for, what kind of a cycle range we can expect from these processes, and type of molds that are being in practice generally, and how much usually they cost, and what kind of mold life we can expect from each of them. This table gives you an overview of these 6 different close molding processes. So let us look at resin transfer molding more in detail now. Resin transfer molding, which is also known as RTM process. RTM is a vacuum assisted resin transfer process with a flexible solid counter tool for a B surface compression. This process yields increased laminate compression, a high glass to resin ratio, and outstanding strength to weight characteristics. RTM parts have both side finish surfaces, both A side and B side. Reinforcement mat and oven drawing is placed in the mold, which is then closed and clamped. A catalyzed low viscosity resin is pumped in under a high pressure, displacing the air vent at the edge until the mold is filled. Molds for this low pressure system are usually made from composites, nickel shell faced composite constructions, suitable for medium volume production of a large components. Resin transfer molding is usually considered an intermediate process between relatively low spray up with the low tooling cost and faster compression molding methods with a higher tooling cost. Recommended for a product with a high strength to weight requirement, best suited for medium range production rates in the range of 200 to 10,000 parts a year. Gel coat may be used to provide a high quality durable finish for the surface. Tooling can be made from a different material, be it polyester, nickel shells, aluminum, even mild steel. The volume and the life of the tool is based on the material we use for the tool. Let us look at now vacuum infusion process. This is also known as VIP. VIP and the RTM light are vacuum assisted processes. I will give you a more overview about RTM light later. The closed mold resin process. For a compression of the B side surface, the vacuum infusion process uses a flexible sheet or reusable bag, and in RTM light it implies a lightweight counter tool or a B surface, unlike in full RTM which is heavy. The process this process yields increased lamination compression, a high level of glass to resin ratio, and excellent strength to weight characteristics, almost similar like RTM process. With these process, the reinforcements are placed same like in RTM process in the mold, dry, frequently combined with the cores and some other special inserts. Vacuum is then applied to compact the reinforcement and eliminate the air. Resin is introduced and vacuum draws it through a reinforcement. Very large parts can be made out of these vacuum infusion process methods utilizing very low viscosity resin and appropriate fill time with the bleeder film and other vents. These resin infusion process results in very low void content and excellent mechanical properties. Due to relatively high glass content, fiber content is determined by the fiber and architecture of the pressure. In the figure, you see a kind of vacuum infusion process representation. The one you see in the red or pink is the mold, and you have an air vent or the vacuum vent in the side of the process, and in the center we have a resin pouring the wall and vacuum bag. So let us look at RTM light. Resin transfer molding or resin transfer molding light. This is what generally known as. In this process, resin is introduced via pumping mechanism under a low pressure, usually less than 2 pascals. More flexibility in terms of resin and fillers is possible, and an intermediate range of fiber content. Benefits are better cosmetic finish and variation in the part thickness and faster cycle time for a low cost tool and the tool can also be of aluminum, steel or composite. Recommended for a product with a high strength to weight requirement or with a slight design returns, edge overhangs or high draft angles with what would cause a die lock on a rigid B-side mold surfaces. Best suited for a mid-volume production like between 200 to 5,000 parts a year. And environmentally friendly, this is a closed mold process, involves no resin exposure to environment. Pre-placed reinforcement can be employed to achieve optimum strength and weight ratios. In-mold gel coating finishes can be employed for a desired cosmetic finish. Volume recommendations are average and provides only a general guideline. Actual volume efficiencies are more complex matter requiring a detailed statistics about the part to be manufactured. So the volume suggestions said here are more for a guideline and there is no hard and fast rules. The picture represents how the light RTM construction is. Here you can see there will be an vacuum clamping, then vacuum cavity, resin pouring, and light B-side mold. The one you see in the pink here is the full side, the solid mold. Now let us look at compression molding or sheet molding component or bulk molding component, which are more or less a compression based molding process. So compression molding is the most common choice for high volume composite parts and often associated with these processes called SMC or BMC, basically sheet molding component or bulk molding component materials. These processes produce a high strength, complex parts in a wide variety of sizes. Machined metal dies are mounted in a hydraulic mounting press or molding press. The material charging is manually or robotically placed into the mold, and in this process mold is heated. The heated molds have they will be closed with high pressure is applied. The cycle time ranges are highly very fast compared to any other processes we have discussed so far. Usually it is around 5 minutes depending on the size and thickness of the part we would like to manufacture. And we can there is a greater flexibility in design features of adding ribs, bosses and inserts can be molded in. Compression molding parts are characterized by a net size and shape, two excellent finished surfaces and outstanding part-to-part repeatability is possible in this process. Trimming and finishing costs are very minimal. In-mold coating are available to improve the surface paintability and eliminating the need for primer or color compound, and we can use a color compound also to customize. Male and female tools are commonly made from a tool grade steel where the pressure is almost 28 bar. Other tooling material can also be used based on the type of part and type of machines we employ. Tools are generally capable of running a temperature of 150 degrees centigrades and pressure about 68 bars. Depending upon the counters, the tools are generally run for 60,000 parts before a restore activity has to be done on them. Now let us look at liquid composite molding. Liquid composite molding process with a pre-placed reinforcement. It offers a similar performance and character, same like sheet molding component or bulk molding component process, and similar cost and volume benefits. The key distinction between those SMC or BMC or LMCs, LMC is more concentrated mechanical properties can be achieved. The key distinction is superior structural efficiency that improves the mechanical and cosmetic properties of molded parts. This advantage makes it popular for high volume automotive and truck parts that requires a greater structural integrity. Use of pre-placed reinforcement, precisely aligning the fibers with the load set for the product. This results in improved fiber efficiency and low cost per weight. Use of advanced robotics minimizes the variation in the fiber as well as the labor content, further enhancing the performance. These factors are explained the design allowable and reduced energy cost. We see two pictures here. Basically, the first picture which talks about preparing the pre-fiber enclosure, and the one more picture or the table what you see here which gives you an overview about how concentrated range of tensile strength between these two processes. Like you can see, the range of liquid composite molding is very tight band compared to the sheet molding compound. Now let us look at reaction injection molding. DCPD is also a thermoset material and parts are manufactured through reaction injection molding, which involves a closed tool and low moisture and low oxygen environment. It is similar to injection molding process, except that thermoset polymer is used